Morning. Children, today I would like to discuss the new term evaporations. Before this term, I would like to tell you by applying temperature and pressure, we are able to change the state, that is a solid to liquid and liquid to gaseous state. By applying heat, we converting solid ice to liquid water and liquid water to gaseous water. And by applying pressure, we are able to convert gaseous carbon dioxide to a solid carbon dioxide. We know that matter like solid, liquid and gases are made of small particles and they are not fixed. They are vibrating in a given boundary. But when they getting heat energy from the atmosphere, their kinetic energy will be rise. Their kinetic energy being increased. As far concerned with the liquid particles getting too much kinetic energy and they are getting such an energy, they are able to break the force of attraction and they convert liquid state to gaseous state below its boiling point. So we can say that the evaporation is a process in which the liquid substances converted into the gaseous phases by applying heat energy below its boiling point. Let's discuss the difference between evaporation and boiling process. In evaporation process, we find that the vapor pressure less than the atmospheric pressure. So that's why in this case, bubble cannot form. But in the case of boiling, the vapor pressure is equal to atmospheric pressure. So that's why here we find that bubble can form and they rise. So we find that evaporation may be start at any temperature, but boiling must be start at 100-degree temperatures, and here we can say that evaporation is a surface phenomena, but whereas a boiling process is a bulky phenomena. Now we can say that in an evaporation process, physical conditions having a great role, they influences, but in a boiling process, physical condition having no effect. Now, cooling causes by the evaporation process, but cooling is not caused by the boiling process. This is a basic difference between evaporation and boiling. Factor affecting rate of evaporations. First factor, surface area. Second is temperature. Third is humidity, and fourth is speed of point. Now discuss how surface area influences the rate of evaporation. Actually, the larger surface area influences the rate of evaporations. If the surface area is large, then rate of evaporation will be also faster. So we can say that rate of evaporation is directly proportional to the surface area. Surface area increase, then rate of evaporation will be also increase. Rate of evaporations also depends upon the temperatures. We know that temperature having a great role to influencing the kinetic energy of the particles. When they getting the too much kinetic energy and they this kinetic energy having ability to convert the matter from one phase to another phase. So that's why when we increasing temperature, the rate of evaporation will be also increased. Rate of evaporation will be indirectly proportional to humidity. Humidity means the amount of water vapor present in air, and so that's why if humidity is larger, then rate of evaporation will be slower. So we can say that rate of evaporation is indirectly proportional to humidity, and rate of evaporation is directly proportional to wind speed. It is a common observation, clothes dry faster on the windy day. So we can say that the wind speed will be larger, then the rate of evaporation will be also enhanced. So we can say that these are the factors having a great role to influence the rate of evaporations. How does evaporation causes cooling? Yes, evaporation causes cooling. We know that evaporation is a surface phenomenon where the particle on the upper surface gain energy from the surrounding and leave the surface. As the particle take away energy with them, they result decrease in temperature of remaining liquid, and so they as cause cooling effect. Now I'd like to discuss the earthen pot. Here this earthen pot, this is a matka, becomes cool during the summer. We find that there are some pores in earthen pot. When water from inside the earthen pot seeps into its wall through the pores, the particle of water on the wall absorb energy from the surrounding and evaporate into atmosphere. Since this energy is taken from the water itself, and this leads to the lowering of temperature of water in the pot, and that's why water kept in earthen pot, that is a matka, becomes cool during the summer. Now we find that water kept, that is a cold water kept in glass. Actually, when we see water droplets on the outer surface of glass containing ice cool water, in this phenomena we find that the water vapor present in air on coming in when it's come in contact with this glass, it loses energy and get converted into liquid state, and we are just observe in the form of water droplets. Okay.